G'day everyone and welcome back to the channel. I'm going to get started laying out this PCB now. So I'm just working out the layout for the IC itself, and then I'm going to lay out all my tracks and everything. I mean for the most part a lot of the layout's going to be quite similar to this, because the two inputs are that pin there and that pin there at the end left of this IC. So obviously the input traces are just going to go straight like that and like that, you know. The output is this pin, and the pin next to it's the feedback pin, so that's obviously going to be the same too, except for between this pin and there we're going to have a little feedback network. The only other pins I've got to really concentrate on are the power and ground pins. Sorry, the plus, minus and ground. I'll get this right in a minute. The plus and minus pins and the ground plane. Anyway, so what I'm going to do is I'm going to lay out my inputs, my output. Then, well, I'm starting off with just the pins of a IC itself. Once I've got the 8 pins there, I'm going to lay my input and output traces, then do the feedback network, then the power traces, and then I'm going to start filling in all the ground area and stitching. Or the stitching will just be little holes, dots representing where the holes will be. So yeah, I've never tried to make a PCB for surface mount components before by hand, so this is going to be quite interesting. I mean, I think I've got something on hand here. No, they're all in my power supply. I've made PCBs that have got like 1 or 2 surface mount parts on the PCB, but the rest of it's all just through-hole components. But yeah, I'm not used to working with stuff this small, and you know, pin pitches that are this small, so it's going to take me a little bit to lay it out, but that's okay. So it is what it is. I'll be back when I've made some more progress and we'll talk about what we're doing. Okay, making some progress on the board. I'm just going to take the image lock off so I can bring it up to the camera, because from a distance with all the scratching on it, because what I've been doing is using the ruler. I'm using a combination of a ruler. I just realised what I did then. A ruler, a fine tip pen, a thicker tip pen, a little Dremel bit for scratching, like by hand, and then I've got Q-tips too. And another technique I have also is to break the Q-tips, and well, I use the Q-tips with IPA to remove mistakes. But if it's a really small spot, you can also get, I can't spray this because it's all going to land on the board, but you can get that bit wet and get in on a, you know, like a tight little spot and get rid of what you need to get rid of. There's a few ways of doing it. You can scratch it out, you can rub it out, you can rub it out with that or that, you know, or wash it because you're using IPA. But anyway, I'll move this up to the camera because it's actually way neater than what it looks down there. Yeah, just on the bench it actually looks bad because of all the scratching, but it's just the light reflecting. It's the same with the marker. The marker looks funny because there's 2 types of marker on there. But I tested this in a previous etch, and it etches fine with both markers and FC. So I've still got a bit to do, not too much. I've got to continue the ground across here, so I don't know, like roughly about there and there. It's got to be blacked out. Got to finish this bit and this bit. And what else? Got to put all the holes to stitch the ground planes together. Got to decide where the capacitors and the 1 meg resistor are going on the inputs and the output. Yeah, that's basically it. It's getting there. It's coming along. Anyway, I wanted to show you guys what I ended up using for the PCB calculator, because I was looking at the other calculator and I came to realize it didn't have the ground plane either side of the signal trace, so I found a coplanar waveguide calculator. And that's, you know, all the figures in there. This is what I've come out with. It's not 100% perfect, but it's close enough. And for a board this short that's only running up to 100 megahertz, it's perfect. Also, it makes it easy for me to do this by hand. 3mm, 1.5. You know, even that's tricky to do with a pen by hand, but it is doable. I'll just show you. If you look at my track, it's 3mm, and if you look at the gap, it's about 1.5. It's not all perfect, but you know, like I said, when you're at this smaller length, and don't forget this has got to get cut down. I mean, like the actual board itself, it's going to have probably this much missing off each end of it, at least. Maybe about that much missing off each end of it. Yeah, probably about that much. And probably about that much missing off the sides too. Like the board's going to be smaller than this one, or at least the same size or smaller. It's definitely not going to be bigger. So yeah. Anyway, I don't want to keep just wafting on and bore everyone, so I'll get this finished up and I'll come back when it's done. We'll etch it up, start populating it, and see what we get. I'm thinking, honestly, I know a lot of people are going to laugh at me for saying this. In future, when I need to do something small, like RF or just surface mount in general, to be honest with you, I think I'm going to start learning how to use CAD software. I've always tried to stay away from it for years and only use it when I've absolutely had to, and I'm absolutely crap at it, but I think it's worth the effort to, you know, learn how to use it better, because this is bloody annoying trying to do this with a pen. You know, like, it's tricky. I can tell you that. When you're just doing it freehand for 3-hole components and you're not running up at high frequencies, you know, it's so much easier than this. So, yeah, I still enjoy making my own circuit boards by hand, but just not for this kind of stuff. This is just a little bit too much. Anyway, I'm still going to finish this one. Possibly the next one or two as well. I don't know, we'll see. I think maybe I might do the next one by hand and then do this one on a PCB that's, you know, done through JLC or something like that. But yeah, we'll see. Anyway, I'll be back soon when I've made some more progress on this board that I've just noticed has a scratch on it, and I don't know how that got there. That's not good. Cool. I mean, I'll go over it before I put it in the ferric chloride anyway, and just make sure there's no scratches anyway, because I'm trying to get this as perfect as I can get it. Alright, I'll be back soon. Alright, I've made some more progress. I thought I'd just come and give everyone a quick look. That's where I'm up to at the moment. I'm actually pretty impressed with it, to tell you the truth. There's a couple of things I didn't do perfectly in retrospect. It would have been better for me to run these power traces that way, sort of. I'm going to put the capacitors on this side of them, obviously, so they're not coupling to the side of the ground plane that's closer to the inputs, but I could have done an even better job of that if I put them further forwards and moved these components in a little bit. The capacitor and resistor that goes here, and the resistor to the ground that goes there. If I moved all that in a bit further and put the power traces a bit more that way, it would have been a bit better. And the other thing I mucked up, which is a little bit silly, is the output line. I don't know if you can tell, but this is actually all separately drawn. I didn't just get a ruler and run it straight through. If I pick the board up, you can actually tell there's a slight offset. They're actually two separate tracks, and I screwed that up because I actually meant to draw that angled in even more than what it was. So when I cut the board back, it ends up in the middle of the board, but it is what it is. It's okay. Anyway, you know, lesson learned for next time I'm laying out a board. But yeah, so I'm just gonna have a little look at this, have a think about it. You know, make sure I'm happy with everything, and if I am, I'll go off and I'll start working out the space for the ground stitching holes, and then I'll start putting all the ground stitching holes in. I think the way I'm going to do it is basically just by drilling holes and putting little bits of wire through them, but I haven't decided 100% how I'm going to fill the V's yet. I saw in someone's video, I can't remember what it was, but I saw something, someone was talking about in the old days, some circuit boards, the V's weren't plated through holes, so you'd either have to use something called a V stitch, which was like a piece of wire that went through the V, or flood it with solder. Now, excuse me, I can't understand how you could flood it with solder without it being plated through, so I can't see that working really, but if it does, I'll do that because it'll be a lot easier, and I'm not really worried about the resistance of it in this case. It'll be fine. So yeah, I've got to look into that too. How am I going to actually stitch it together? I know what I'm doing. I'm drilling holes, but I don't know what I'm putting through them. If it's going to be wire and solder or just solder. So we'll get there when we come to it. Might as well just quickly point out the way I've done this. So these two components, the 1K and the 1.5 picofarad, that's right. 1.5 picofarad and 1K resistor, they sit just across those two tracks there that go this way and this way. So you have your resistor and capacitor. The 10K resistor to ground just goes there. My cat's just knocked something heavy over. I've got to go in a minute. The decoupling capacitors, the 10 mic and the 100 nano, they're going to go basically one there, one there, one there, one there, if that makes sense. Oh, God, I'm a bloody idiot. You know what I haven't done yet? I haven't worked out where I'm putting my input capacitors and my output resistor. I've still got to cut the track to add those parts. So yeah, I've still got one more thing to do before I go over this and make sure I'm happy with it. But anyway, that's where everything's going. Obviously, inputs, output. Power's coming in on each side. I'm not going to even try and make traces smaller and run them in between pins or something like that. That's just bonkers. I was thinking about going through the board and running the traces on the back of the board, but honestly, I think this is fine. It's going to be in a little box. The cable's just going to come in and just get soldered straight to the board, you know. Like, well, it'll be positive, negative, and just ground somewhere. I don't know, probably here. But yeah, so that's the way I've decided to do that. All right, I'm going to go do a bit more work on this. I'll get this finished and come back and we'll make it up. All right, I'm just going to take the autofocus off. Turns out that the same rules do apply for, well, the output I've worked this out for, because I wasn't sure going up higher in frequency range if there was some sort of extra calculations or if the same rules apply, just output resistance as close to the source as possible. So, hello little man. It seems that the same rules apply, so my 1 meg resistor is going to go there. Incidentally, I want to point something out here. The input and output traces are all 50 ohms on this board, even though the output is going to be a 1 meg output. The reason why is, well, you can get away with it because it's going to be like yay long, but the trace would have to be that skinny. I don't think I could etch it. I don't know. I'll do a bit of research before I make the next board up and I'll see, but I don't know. I think for one, because of the length of the board, it's too, it's under that 1/10 wavelength rule. I think because of that and because of the difficulty of trying to do it, I just think it's probably something that, you don't do. But cats. I've got a few cats in here now. The little ginger one. Hey, why do you keep doing that? No attention for you. That was not good. Little man. What are you doing? I can't tell if he's playing or if he's trying to actually attack the kitten. Haven't had any problems yet, but I don't know. I don't think them two get along too well. Anyway, so I just completely forgot what I was saying because there are cats in here now. This is the thing that's not good about working around animals. They can distract you. Anyway, hopefully I said what I was going to say. What I've got to work out now is where the input capacitors go. Again, does it not matter because it's so short, or it doesn't matter and I can get reflections or something like that at the higher end of the signal if I put the capacitors in the wrong spot. I understand basic layout, like differential traces need to be symmetrical to each other, component placement on the traces needs to be symmetrical, all that sort of thing. I get that, but how far up and down the traces the two need to be, I'm not sure about. So I'm going to go research that, come back. That's the last thing I've got to sort out on this, and then it's just time to start stitching everything that's ground basically through to the ground on the other side and then etch it. So we're not far away, we are getting there. Okay, so I've just done some research, and from what I can see, the same rules apply again. So the input capacitors just go as close to the input pins as what you can get them. If anyone knows that that's not true at high frequency and there is some sort of calculation to be done for how far up or down the line your capacitors and resistors and stuff like that goes, leave it in the comments section, because I'd be interested to go and take a read if someone could point me in the right direction on some information about that. Because all I'm finding is just the same rules, general rules apply, so that's what I'm going to go with. So I'm going to add the input capacitors basically, there and there, just like I did with the output resistor. So I guess we're pretty well done. I'm just going to do that now, work out how much I'm going to cut it down. I might make these power traces just a little bit shorter and bring that black in a little bit more, so I can make the entire board smaller, because I'm going to cut this down, like it's only going to be, it's going to end up being smaller than the original one, or about the same size. About the same size, maybe smaller. So, but other than that, that's it. And like I said, I've got to stitch the ground planes together. That's something else I've still got to have a look at. I haven't worked out if there's, because I remember reading this ages ago when I was reading some article about high frequency PCB layout, and I'm pretty sure there is some sort of calculation to do on how far the ground stitching vias go. So I'll have a look into that too, and I'll be back in a moment and I'll tell everyone what I've come up with. So okay, so I've done a little bit of research on via stitching, and basically what I've come up with is that it's the same 1/10 of the wavelength, but the difference here is, since the wavelength is going to be shorter on the PCB due to the dielectric of the material of the PCB, for this it's going to be around 4.1, I think I worked it out to. not incredibly important. Nothing's incredibly important in this because it's such a small thing, but I'm trying to do everything by the book because I'm trying to learn high frequency layout and stuff, so I'm paying attention to all these things. Anyway, so sorry, 4.3. Wait, really? Yeah, right, okay. 4.3. I'm just gonna adjust the 4.1 on my PCB calculator. I just want to make sure that I haven't screwed up my traces too much. 4.3 with track width of, sorry, I typed something else in here, so I had to reset a couple of values. Okay, so that's going to come out to 48.67 ohms. Well, it's close enough, and let's be honest, these traces aren't exactly 3 millimeters and exactly 1.5 millimeter gaps, so yeah, it's fine. Like I said, the main point here is to learn a lesson, not that it's going to make so much of a difference in real life on such a small section of board. But anyway, back to what I was getting to. With the PCB dielectric being around 4.3, it works out closer to your 3 meter wavelength at 100 megahertz. Comes out closer to, sorry, I can't think, 1.5-ish. So then 1/10 of 1.5 meters is 1.5 millimeters, right? So yeah, I'm going to go with that because I was thinking around about the 1 to 2 millimeter region myself. That's just what felt right. 1.5, yeah, that's fine. I might go 2 at the worst, but what do they do on this board, just out of curiosity? It looks a lot more than 2. No, 1.5. Okay. Well, I think I'll do that then. I'll do 1.5. I might actually have to go and get smaller drill bits still. Let me just go see, because the drill bits I've got at the moment, they're not small enough to drill the holes and have them, you know, a tight spacing for normal component legs, like resistors and small capacitors and stuff like that. So I can't think what size bit that is, but I'm missing that. I've broken all the ones I had, and if I want to get my vias close, like 1.5 mil close, I'm probably going to need that bit. Let me go have a quick look and see what I've got. I'll be back in a moment. Alright, I've had a look and it's not going to happen with what I've got. I'm going to have to go get some very small drill bits tomorrow. That's okay. I mean, it's a little bit annoying because I wanted to do this tonight. I wanted to, it's 9:55 now, and I wanted to drill the holes and etch this up at least so that tomorrow I'd have a ready board, but it looks like tomorrow I'm going to have to go to Bunnings or somewhere like that and get some small drill bits. Okay, well, I've done a bit of thinking. I think what I'm going to do is I'm going to etch the board up because I'm going to be drilling the holes after I've etched it anyway. So I etch the board now, and then I'll start sorting out components because I've got to go through all my surface mount stuff and see if I've got, I mean, I don't know exactly what type of capacitors these are. I want to find good quality capacitors. Yeah, I've got to have a little look around. I've got to find a 1 meg SMD resistor. I've got to find decent capacitors. Oh yeah, and the decoupling capacitors for the power lines too. So yeah, that's what I'll do is I'll etch the board, I'll get all the components ready tonight, so then in the morning I can just get the drill bit, drill the holes, add the components, and Bob's your uncle. So that's the plan. I'll go set up now for etching. Well, this etch is going to be a little bit more difficult than my usual etches because last time I was packing everything up, I dropped my plastic board tweezers on the floor and stepped on them, and they're now in two pieces. Anyway, here's a little up close look at the PCB. I've gone over it, you know, just a couple of areas that looked like they're a little bit thin, and a few things that weren't straight enough for my liking. I've gone over again, but that is it. So in there it goes. I'm going to go warm up this and then come back and we'll get this etched. Okay, in with the ferric chloride we go. I have to say, I really like how the FR4 just sinks and that phenolic PCB floats. Well, I don't like the way it floats. I like the way the FR4 sinks, and I don't like the phenolic based stuff. I wonder what the impedance is like on the phenolic PCB. I'll have to have a look into that. Not because I like it, I'm just curious how terrible it is. Or good. Who knows? Alright, I'll come back when we've made some progress and we'll have a look. Okay, so I've got some rather sad news. I reckon a few people probably picked up on it. And no, it's not this corner of the board that looked rough and did come out rough. That was just all done with... Oh, where is it? Pen's gone. Oh, one of these pens. And I hadn't gone over it with Sharpie. Turns out this doesn't work as good as Sharpie with the ferric chloride. No, this is where I screwed up. I forgot to cover the back. Time to start again. Oh, God. I did want to put that trace and that trace going a little bit more this way and move those traces forward and this trace to ground forward and this pad to ground forward, so it gives me an opportunity to do that. But yeah, I screwed up. I have to start again, so I'm not going to even go any further on this. I'm just going to upload the video as it is for now. You can all see what conclusions I've come to and what's happening, but unfortunately I didn't get it finished. It sucks, but it is what it is. I've still got to get drill bits to drill the via holes anyway, so tomorrow morning I've got to take one of my cats to the vet first thing in the morning. After that I'll be going and getting drill bits, and then I'll come back and I'll do this again. It's just coming up to 12 o'clock, so I'm going to bed now. I'm not doing it tonight. So yeah, it is what it is. Anyway, that's all I've got for now. So I'll see you all tomorrow. Thanks for watching.